We've mentioned a couple of times throughout this discussion measures that are sensitive to skewed data sets or extreme values. We want to circle back to that idea and look at how this relates to choosing between the mean and the median, which are two different measures that get at answering the same question. What's the center of our data set? What's the typical or average value in our data set? We've talked about identifying skewness visually already. And as a brief refresher here, our first example, our first histogram that we have, is an example of a data set or a histogram that would be approximately symmetric. Then we have a left skewed histogram or a left skewed distribution and a right skewed distribution, a right skewed histogram. What we'll look at in our last two examples is calculating a numerical value for skewness, which comes in handy for verifying our conclusions, or when we have smaller data sets and we can't necessarily see these patterns very well. So if we calculate our value for skewness, one option is that we'll get a value between -1 and 1. If that's the case, we would refer to our data as approximately symmetric. If we have left skewed data, then our skewness would come back as something less than -1. And right skewed data would come back as greater than -1. I'm sorry, greater than +1. If we have data that's approximately symmetric, so that skewness value is between -1 and 1, then the mean is our best choice for measure of center. We prefer it because it takes all the data values into account. So again, in that sense, it's considered to be more accurate. But if we have skewed data, the mean could be inflated or deflated based off some extreme values. So we'll use the median since it's more resistant to skewness and extreme values. In example 6, we have this table on the violent crime rate under President Obama, again, that we'll take a look at. What we want to do is calculate the skewness for this data and use that to identify the appropriate measure of center. To calculate skewness, we use the formula 3 times the mean of our data set minus the median over the standard deviation. And then we'll compare that result to the guidelines we established above to see what kind of skewness or symmetry our data has. So we'll literally just type in this formula, 3 times the mean of that first data set that I've already copied over, minus the median of that data, all over the standard deviation. And I jump back and forth between data sets here for some reason, so let me fix that. This should be the same letter in each case because I should be calling on that same data set each time. And we get a skewness of 0.0928. This value is definitely between -1 and +1, meaning this data is approximately symmetric. And while previously in example 3, we used the median to find the measure of center, the appropriate measure would actually be the mean. Again, because that's the more accurate measure, since it takes all the data values into account. And if we calculated the mean of this data, we would get 388.59. If we compare that to the median that we found earlier, that median was 387.9, what we see is that these two results are very similar to each other, but we throw out the median since it's less precise, it's not taking all the data values into account. The two measures are pretty similar, but the mean is the stronger measure since it's taking all that data into consideration when we complete that calculation. In example 7, we have some new data. The murder rates per 100,000 people for 2021 in different regions of the world. So the Americas, Africa, Oceania, Asia, and Europe. I've already got that data entered, and we want to calculate skewness again. Now what I'll do is just update the data set that I'm calling on, so that I'm calling on this L data set instead of M. And we get 1.964. This is clearly larger than +1, meaning that we have right skewed data. Since our data is right skewed, our most appropriate measure of center would be the median, which in this case would be 2.9. For comparison, if we calculated the mean of this data, we would get 7.02. That average is larger than the majority of our data values in our data set. It's getting artificially increased by those two extreme values that we have for the Americas and Africa. So in this case, we want to rely on the median as our better measure of center, since it's less sensitive to those extreme values and the skewness in this distribution.